Good morning, everyone. Back to where we are. We are going to talk about set theory, which is in MTH 101. And I hope you watched my video on that sequence and series, and you are able to understand most of the fundamental principles of sequence and series under AP and GP. Now we are going to set theory. Now, according to my own definition here, a set is a well-defined collection of distinct objects called elements or members. Sets are usually denoted by capital letters A, B, C, and so on, and elements are listed inside curly braces. These are what we call curly braces. So when we are talking about sets as a whole, set is like a body. Do you get me? As we are humans here now, we are a body. And inside the body, we have the what? The soul. And we also have the mind. So that's what the body entails. So the body is what we call the set, while the mind and the soul is what we call the elements. We can also refer elements as what? Members too. So here now, A is what? This particular notation is what is equivalent to what? Capital letter A means what? A is an element of what? Set A. Why this one means A is not an element of set A. Then cardinality. Cardinality means that the number of elements in set A, it can also be set B. It's only not referring to only set A alone. It can refer to any set. But the meaning of cardinality is number of elements in any set. Do you get me? Now we now have what we call empty set. Empty set means a set with no elements. A set with no elements. That is, they can give you a particular question. I will tell you it's an empty set. So if you should see that it is an empty set, that means there's nothing inside that thing. Empty means null. Now we now have the universal set. Universal set means the mother set of all elements. Your textbook, which is such as hidden facts in mathematics, the meaning of universal set is the mother set. I think it's inside here. So the mother set is like, let us say a mother giving birth to children, and the mother is the pioneer of the children, is the one that gave birth to them, that's their blood and everything. So in that particular case, the elements are known as the children, while the mother is the what? The mother set, which is known as the universal set. We now have methods of describing sets. We have the roster notation, we have the set builder notation. According to some textbook, they write it as set builder notation and roster notation. So here now, I said roster or tabular method. So roster and tabular method only list elements in any form. That is, it is not under a specific rule. In this particular example here, you can see that A is equals to 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. That is, they are listing all the elements. But in set builder notation, it is describing a rule or a pattern. In this particular case, they combine everything together under a rule. Like this particular case here now. It said x is such that x is a natural number. That is, it is what? Less than or equals to 5. Now, in this particular case here, we know that natural numbers are known to be what? Counting numbers. And counting numbers starts from 1, 2, 3, 4 till infinity. So in this particular case here, they said x is such that it is what? Less than or equals to 5. So anything that is less than or equals to 5 starts from where? 1, 2, 3, 4, and 5. So you can see here, this particular thing also means the same thing that is here too. But the thing is, this one has already compiled all these numbers as a what? As a natural number here. So we have known the difference between these two methods of describing sets. Now we now have the word set operations, which you need to know. So first of all, we have the union set operation, which says that what? Elements in A or elements in B or both. So union means what? A combination of what? The element in A and the element in B together, or both. So this is how the notation looks like. It says that x is what? Is an element of what? Set A, or x is an element of set B. So you put them together, that will form your what? Your union rule. But for this particular case here, we have the intersection. Intersection means that elements common to both A and B. Elements what? Common in both A and B. In this further example, it is denoted as this. X is an element of A and X is what? An element of B. So you can see here in this difference here, you can see or here. But in this particular case, we put and. So in this particular case here, you can see that there is a difference between the two of them. If they say or and, they mean two different things. Or it can be or might not be. Well, this particular case, it means that it must be. So this is and here. So here now we have complement. Complement says that what? Element in U, that is the universal set, which we have talked about to be the what? Mother set of all elements, but not in what? But not in A. So in this particular example here, there's a notation about it saying that what? X is an what? Is an element of what? The universal set, but it's not an what? An element of what? A. So if you say that the element of the universal set, that is 1, 2, 3, 4, 5, which is the universal set, then the element of A is what? 3, 4, 5, 6. 3, 4, 5, 6. So in this particular case here, we only count the elements in U, but not the elements in A that are not there. So you know that in elements of A, there's what? 3, 4, 5, 6, while in elements of B is 1, 2, 3, 4. So we only count 1, 2 for the universal set. Another as what? As an order of complement. But in difference here, they said A minus B. This A minus B can also be written as what? B minus A. This A minus B, in my own simple terms, I can say that as what? A only. That is what? A only. That is elements in only set A only. So in this particular case here, elements in what? Set A only, but not in what? In set B. So this is the particular notation here which you must note down. Then we now have the Venn diagram. Venn diagram consists of what? Overlapping circles in a particular rectangle. This is a rectangle here. This is a rectangle. We have overlapping what? Circles on it. So this, it can be written as this, it can be written as this, and it can even be written more than this. We can write it as 4. 1, 2, 3, 4. Yeah, depending on how the question is or what it entails. And we have the rules here, which is number of A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Number of what? Element in A union B union C is equal to element in number of A, element in B, element in set C, an element in A intersection B, element in what? B intersection C, an element in A intersection C, an element in A intersection B and C. So these are the intersection rule you're supposed to take note about. So I can give you an example. In this intersection here, we told you one particular thing. Let us see here. Let us say that this particular place is A and this particular place is B. So intersection, let us say there's a number here. This is 3 here. So the peculiar thing about this one and this one is what? 3. So the 3 is the one inside this overlapping circle in between them. So 3 is what? The intersection between the two of them. That is what is common between what? Both A and B. Do you get me? So I've given you an example under what? Intersection here. But for union here, we are only classifying all the elements inside this particular thing. That is the mother of all of them. That is all the children that has given birth to. Those are what we call the what? The union. Now we are going to the what? Examples. Now going to the examples here, we said in a class of what? In a class of 50 students, 30 study mathematics, 25 study physics, and 50 study both. How many study mathematics and how many study neither? Now the solution goes thus. The union set, where is the class of what? A 50 student. That is, they have classified everything to be what? In that particular class, we only have 50 students. I classified this as the universal set. Then they now say 30 study mathematics. I denoted as my mathematics as M, which is what? 30. Number of physics is to be what? 25. And number of people that are studying both as M intersection P to be what? 15. So using this particular formula, which I have already discussed before, we use this formula here to get the what? the um the people that study both maths and physics together. Then we we got I mean the people that study both maths and physics together. They are what 40. Now they now told us in this question that how many study mathematics only. So in order to get this particular variable, in order to get this question, the solution of this particular thing is the number of mass, which is already 30, minus the m intersection p. What is our m intersection p? That is both people that are studying what? Maths and physics. You want to know the exact number of those people that are studying only mathematics. So anything that we have here, we minus it from here. That's how we got what? 15 here. 30 minus 15, which is supposed to be 15. Now we now have what is neither. We are looking for how many people study neither of the courses. That is, they are not studying what? Mathematics, they are not also studying physics. So we use the universal set as a whole. Since we have already known the people that are studying both maths and physics, we remove it from the universal set. So the number of people that are studying both mathematics and physics are what? 40, which is already here. The universal set is said to be what? 50. So 50 minus 40 is equal to 10. So in this particular case here, we have found the people that are studying mathematics to be 15, and we have found the number of people that are studying neither of them to be what? 10. So example number 2 said if A is such that 1, 2, 3, 4, and B is such that 3 is equal to 3, 4, 5, 6, find A union B, A intersection B, and A minus B. So we are looking for the union, we are looking for the intersection, and we're also looking for the difference. Now listen attentively. For union, I told you that the elements in A and B combine to each other. So here now, in this particular case, in order to take a note of union, we don't repeat the numbers that have already been shown here that are like to each other. So here now, you can see that this particular case, they have 3 and 4 and 3 and 4 in common. We don't need to write it twice. We just combine them together as a whole. So A union B is said to be what? 1, 2, 3, 4, 5, 6. So we put them together. Since 3 and 4 and 3 and 4 is here, we don't need to write it 2 times. We just write it once. So we are done with what? With finding the answer of A union B. Now we are going to A intersection B. A intersection B, according to intersection, we said elements common to both A and B. What are the elements common in both A and B? We have what? 3 and 4. 3 and 4. So here we write what? 3 and 4 to be what? A intersection B. Now we are looking for the difference. Now the difference between the two of them is what? What we are in order to know the difference. First of all, A minus B. To what I've said before, we said A minus B means what? A only, and B minus A means B only. So we are only dealing with only sets in A. If we should minus the elements from B that are common to each other. What are the elements common to A here? We have 3 and 4. So we cancel what? 3 and 4 here. And 3 and 4 here. But we're only dealing with A only. So in A only here, we only count the elements that are not common to what? B. So which is what? 1 and 2. We put them together. So our A minus B, which is what? A only. A only is what? 1 and 2. So given that now, I hope you have understood the philosophy of set theory, and you already understand the examples I've listed here below. Please like, subscribe, and follow my YouTube channel. And also, you can send it to your classmates if they are having difficult time in understanding simple things in mathematics. Thank you very much. God bless you. See you next time, and look for more. Look more on my videos. Thank you.